187.5283. So we won't do that one either, obviously. So we'll do one of the other ones. We'll do any of these that you guys want to do. And I would recommend not doing this one. This one's kind of boring. These guys up here are the ones that they're going to have more of the interest for you as far as seeing what to divide by. That's the big thing, is the dividing, what we're dividing by. So your call. We have time probably to do one of them. Maybe two. Which one do you want to do? Do you want to do, don't do this one because it's explained for you already, and don't do that one yet. You'll do it to turn in. One of these three. So either 3 with no Powerball.
That one.
This one right here? So 2 with a Powerball. Yes. Why is the chance of buying a Powerball ticket? Is this pointing at the correct thing? Make sure this is pointing at the right thing. Ish. That's good. Getting 2 of the correct Powerball numbers and the Powerball correct. Why is that? Why are the odds 1 in about 706? That's what I want to know. That's what we're figuring out right now. We're going to do this exactly the same way we did the ones in class last time. For sure. For sure. But this one is the one where order doesn't matter. Do you remember why the order doesn't matter when you're playing Powerball?
Because you're filling it out in.
Yes, and be a little louder. Go ahead, my friend.
Well, when you fill it in,
Yes.
it doesn't matter.
Right. If the correct numbers were 1, 2, 3, 4, 5, and the Powerball was 1, it doesn't matter if you colored in 1 and then 2, or 2 and then 1, and handed the ticket in. You got 2 of the correct numbers. You see how that's different than a combination lock? If on a combination lock you go 1 and then 2, or you're like, oh, no, just go 2 and then 1 instead. No, that's not the combination. The combination is 1 and then 2. This is not a combination lock. It's a unordered sequence of numbers. So that's why we have to do the whole division thing. We have to divide to take care of that replication of tickets. So let's do this one. So we're going to get 2 Powerball. Let me shut the screen down. All this is this is already in your take-home exams. You don't have to worry about printing this out or anything. It's already waiting for you guys. Okay. Let's do it. So 2 non-Powerballs plus the Powerball, right? Yay. 1 in 706. Doesn't sound all that bad, does it? Maybe it does. Maybe it does. So, 2 non-Powerball numbers correct, and Powerball correct. Now, in the take-home, I make this pretty clear. You've only accounted for 3 of the 6 numbers you have to pick here, haven't you? You still have to pick 3 more. And what are they going to be? Go ahead, Ben. I'm looking for a 5-letter word starting with W.
Wrong.
Wrong. They're going to be wrong. You've picked 2 correct non-Powerball numbers, which means by definition, you've picked 3 wrong non-Powerball numbers. That's the whole point. They're only showing you on that ticket the ones you got right. Every ticket you purchase has 6 numbers picked. You make more money the more numbers you get correct. But that doesn't mean that you pick any less than 6. You're always picking 6. And you have to account for the ones you get wrong, because they make up quite a few tickets. Does that make sense? Ish? Getting there. We're getting there. We're making this sense. Okay, so how many possible Powerball tickets are there again? Possible
54 was it?
Powerball
59.
tickets. Oh, no.
Oh.
Not, I love what you're saying, Lynn. We're going to need that. We're going to need that. But the number of 175 million something? 175, 223? 510, thank you, friends. Yeah, 59 is the choices we're choosing from, Lynn. We'll get to that in a second, I promise. We'll get to that in a second. I wish it was 59. I'd go buy them all every time. That's how many tickets there are. So if you're looking for a connection between what we did earlier today and what we're doing right now, this is like the 10 billion over there. This is going to become our denominator in our fraction. This is the total number of tickets purchased. Time out. The total number of tickets possible. So your probabilities are all based on a ratio of that number. Our job is to figure out how many have exactly 2 non-Powerballs correct and 3 non-Powerballs wrong and the Powerball correct. That's our job. Okay? Are we settled on the job we have to do? Once we have settled on the job we have to do, doing the job is not that big of a deal. It's kind of like on the exam, I walk you through it sequentially. I break it down by pick this, and pick this. So we'll do the exact same thing here. Okay? So how about the number of tickets with 2 non-Powerball correct 3 non-Powerball wrong, and the Powerball correct. That's what I need to figure out right there. The number of tickets with that situation. If I figure that number out, I take that number, divide it by the 175 million number, and out pops 1 in 706, which is the chance of actually hitting that kind of a ticket. Fair enough? Okay. So I'm going to start it the same way we started all this stuff today, with a line, with 6 spots. I'm going to start it with a line with 6 spots. We're also going to give you part of your answer for that 20-point problem. Even though we're not doing that problem, I give you part of the answer for it right now. Okay? So, come on up here. Thank you, Maddie. Awesome in my mind. I heard Kurt's voice move the camera. That's why I need a staff, so I can pose. 6 months. I think I started putting a square around this last time, I think, for the Powerball. Friends, the number that goes in that spot is always going to be one of 2. It's either going to be the number 1 or the number what? And we used the other number yesterday. You're either going to get the Powerball correct or wrong.
It's either 1 or 34.
It's either 1, Gabe, or it's 34. There are 35 total Powerballs, right, Maddie?
Yeah.
There are 35 total Powerballs.
But there's one right, so it leaves it, yeah.
Yes, sir. There are 35 possible Powerballs. One's right, 34 are wrong.
Yeah.
So the number that you're going to put in this spot is either a 1 or a 34. And since in the one I'm asking you to do, you're getting it wrong, you're going to put 34 in there, aren't you?
No, you're getting it right. I thought we were doing it.
On the one you have to do on the exam, I think you get it wrong. Here, we're getting it right. I'm telling you, for the one you're doing on the exam, you're getting it wrong on the exam on that one, because I think the one you're doing is 4 non-Powerballs correct and the Powerball wrong, I think is the one you're doing. I think that's the one we just saw. Right here, Amy, yes, I agree. This is going to be a 1 in class for this review. But when you go home and do it on the exam, you're going to be putting 34 there because you're getting it wrong on that. Is that fair? I don't want to confuse. I'm not confused, but I'm trying to be generous with information, but also not confusing. Okay, fair enough? Now the beauty-ish, that was a good yawn. Not a good yawn. Now, let's do the same analysis over here with the non-Powerball numbers. Is that okay? There are 59 non-Powerball numbers. How many of them are correct based on the drawing?
2.
Well, we're getting 2 of them correct, but there are 5 correct ones, right? We're only going to get 2 of them. I agree with you there. We're only getting 2 of them. There are 5 right, and there are the rest, which would be what, 54 wrong?
Yeah, that's where I was getting it.
Good. That's okay. You got it. We're going to do it right now, Lynn. Now, I love when I heard 2. You guys, whoever said 2, we're only going to get 2 of them correct. I agree with you on that. We're only going to get 2 of them correct. But there are 5 possibilities of right ones for us to get 2 of. So, for example, if the correct numbers that were drawn were 1, 2, 3, 4, 5, we could either get 1 and 2, 2 and 3, 3 and 4, 1 and 5, 5 and 2. You see all these mean 2 correct. Is that fair-ish? So that's what I'm going to put, and this is what's so beautiful. It doesn't matter where you put them. So I'm going to put them right here. I'm going to put right here the non-Powerball numbers that we got correct. I'm going to put our non-Powerball numbers that we got correct here, which means in the last 3 spots, I'm going to put in the ones that we got wrong. Because we have to account for those. There's way more ways to be wrong than there are to be right. That's why the game pays like it does. So here, in these 3 spots, I'm going to put the non-Powerball numbers we got wrong. And this guy right here is the Powerball. I'll make him red because that's what the Powerball is. Now let's just start this like we did everything else today. In other words, let's pretend order does matter momentarily, just momentarily. We're going to correct for it in a second. The correction is what I think threw you guys off yesterday a little bit, so we'll deal with it right now. There are 5 correct non-Powerball numbers. We're only getting 2 of them. So how many choices do we have in the first one? Be brave. Be brave. We have 5 choices. If it's 1, 2, 3, 4, 5, we had any one of those 5 choices to pick. How many for the next one?
4.
It's 4 because we can't use the same one again. That's very, very key. As Amy pointed out, once we color in one number, you can't color that number in again. So it's 5 times 4. Done. Right there. That's correct. So far. What goes in these 3 spots?
54,
54,
53.
53, 52. Boom.
Bang.
Not actually, boom. It's not a bang. Do you see why it's not bang?
Yeah.
Yeah, we're not going all the way down to 1. It's a partial. I'm going to stop right there. Just when I tell me when it's like, yeah, go ahead. Come in. Lawsuit. So, this is great, except for the fact that we've got too many tickets in there. We've got too many tickets in there, friends. Do you remember why we have to make a correction? Do you remember why? We're going to have to divide this by something, and we're going to have to divide this by something. Each of those 2 chunks, we have to divide by something, and these are actually bangs, believe it or not.
They're 5, 4, 3, 2.
Because of the repetition. For example, when I put 5 times 4 up there, you know what? Let's actually just act the whole thing out. Let's act it out. 1, 2, 3, 4, 5. I want to prove to you why the bang has to be in there. Watch it. Suppose these are the 5 non-Powerball correct numbers. Let's go in there and pick every possibility of grabbing 2 of them. You ready? Let's do it. You keep track. You count.
1, 2, 3, 4.
Okay. That started really crappy and got worse. Let's try it again.
1.
1 plus
1! 2! There it is.
3.
Yep!
4.
Yep!
5.
Yep!
6.
Yep!
7. 8. 9. 10.
10. What's 5 times 4? 20. It's twice too big, isn't it? Why is it twice too big? Because it's counting 1 and 2 as different than 2 and 1. They're not different, are they?
Because it doesn't matter.
Because it doesn't matter the order. So dividing is what takes the order away. So what you're going to divide by is 2 factorial, or 2 bang, which is just equal to 2. That's how you turn 20 into 10. That's how you remove the order.
You just divide it by 2.
Because that's the number of ways that you can repeat but get the same ticket.
Okay, gotcha.
Getting 1 and 2 is the same as getting 2 and 1. Is that fair? 1 and 2 is the same as getting, because as Amy said, when you grab the ticket in your pencil and you shade in the numbers, the person at the desk doesn't know if you shaded 1 and then 2 or 2 and then 1. Because you hand them the ticket's filled in. So basically, essentially, what you have to remember is you're going to divide by the factorial of however many numbers are up here. Because that's how many ways you can arrange those and get the same result. Is that believable? You guys buying that logic?
Mm-hmm.
So what would you have to divide this by? 3 factorial. Because there are 6 ways of arranging those 3 numbers, but getting the exact same 3 numbers. This is the same reason why a combination lock really isn't a combination lock. If you think of any 3-digit combination on a combination lock, 1, 2, 3, there are 6 ways to enter those 3 digits. 1, 2, 3, 1, 3, 2, 2, 3, 1, 2, 1, 3, 3, 1, 2, 3, 2, 1. If you were to color those in on a ticket, that would look exactly the same no matter how you entered them, right? It's the drunks coats problem, isn't it? It's the coats leaving the drunks with the drunks. But it's the drunks and coats from your last project. It's the drunks and coats. ABC, ACB, BCA, BAC, CBA, CAB. But if you were coloring that in on a ticket and handing it to somebody, it would just look like 1 and 2 and 3 shaded in. So when you divide by that, you take care of that annoying repetition. And I'm only saying annoying because it's only annoying because it shouldn't exist in a Powerball ticket. That number, friends, is the number. It is pretty huge, but it's not that huge. It's not that huge. It is huge. It's huge-ish. This is huger. Oh, making up words. Making up words. So our job is to take that beautiful number up there with the division. So you see how you group? Basically, what you're doing is you're breaking this into chunks. The numbers you got right, the numbers you got wrong, and then the Powerball, right or wrong. And the factorial underneath just matches simply how many spots are above it. So yours, FYI, right? You're going to have a 4 bang in yours, aren't you? Because you got 4 numbers correct. You're going to have a 4 bang, which is 24. Crazy! There are 24 ways of arranging those 4 numbers. Why? Because it's the math problem from your last project. Remember when I had you do all those math?
Yeah.
If you were to write the word math down on a piece of paper, I know it's hard to say. If you were to write the word math down on a piece of paper, I would have no idea what order you put those letters in. I would assume you'd go M-A-T-H. But couldn't you have gone H-T-A-M? And it would still look like math?
H-E-H-M.
A-T-H-M. A first, then T, then H, then M. But M was good. Yeah, exactly. There are 24 different ways to put the pencil to paper and create that word. But at the end of the day, it all looks like math. You see? It all looks like math. That's the problem with Powerball. You need to take those out because that's the same ticket every single time. And that's what those numbers in the bottom do. They remove that repetition of tickets. Fair enough? Awesome. Let's do this. Let's do this. Let's do this. Oh, I'm sorry. This took longer than I thought it was going to take. I apologize. I wanted to do more. I think you're getting the point now. I think you're seeing what you have to do for that, the example you have to do on that take-home. And if not, you can always email me.
So pretty much the bang is 54 times 53 times 52 divided by 3 times 2 times 1.
Yes, sir. If that makes it easier for you, yeah. And this is 2 times 1. Yeah. If that makes it easier, that's totally fine. Yep. That's actually, when I first learned this many, many years ago, my prof always used to write that.
That would,
So,
yeah.
hey, cool. That works. That works, man. That works. So, let's take a peek-ski. Let's go over to Doc Cam. This thing fired up, I think. Yep, there it is. Okay, you ready? Let's figure this out. So we're going to have how many tickets? So I've got, let's do this. We'll do across the top first. 5 times 4 times 54 times 53 times 52 times 1, which is nothing. Okay, that's too many. That's, as Lynn said, it's a huge number. It's too huge. That counts all the repeated tickets. So let's take those out by dividing by 2 times 6, which is 12. Everybody get where I'm getting 12 from in there? 2 times 1 times 3 times 2, that's 12. I'm just dividing the whole thing by 12. You can also divide it in pieces. Kurt, what's on your mind?
Well, here I'm taking notes. Now we have 2 times 1 and 3 times 2 times 1.
The whole thing is 12.
No, I understand that, but a minute ago it was divided by the spots above it. So I was just doing for...
But it's the same thing as saying this, Kurt. I love what you're saying. I love what you're saying. If you had the number 50 divided by 2 times 2, would it matter if you divided 2 into 50 and then 2 into 50? Or if you divided 50 by 4? No, that's what I'm saying here. Instead of doing this divided by this and this divided by this, I'm doing this divided by this.
Right, but I have written down in my notes where I've got 5 times 4 divided by 2.
Which is the same thing as I'm doing in a different order.
352 divided by 3.
3 bang, 3 factorial.
Bang.
3, there was an I erased this to replace it with an exclamation point. Bang, 3 factorial. Remember that factorial?
Okay.
Oh, I see what's confusing you, Kurt. It's not the division. It was this. Don't forget it was the exclamation point.
So, okay, so that's, when you write down an exclamation point and all this bang talk, I've got 3 times 2 times.
All the way. Store that number. Bang talk. Oh, see? This number all the way down to 1. That was the confusion. Thank you, Kurt. Thank you. Yes. Well said, sir. Well said. Good, Scott.
Yeah.
I'm just curious, like, on this
Yeah,
equation,
that-
there's 59 Powerball, where's the 54 from?
Because there are 5 correct and 54 wrong. When they pull those 5 out, there are 54 other numbers that are incorrect. Hence the challenge of the game. FYI, when this game first came out back in the late 80s, there were far fewer non-Powerballs. They've been adding to them slowly over time to make it harder to win. Yeah, just so you know. Anyway, here we are. That's how many tickets there actually are that have 2 of these guys correct, 3 of these guys wrong, and the Powerball correct. Fair enough? Divide that by the 175 million, 200, you guys give me 175, 223,
510.
510. Okay, it's about 1/10% of a chance. Now, that does not look like, where are we? We're here, right? That doesn't look like 1 in 706, does it? But wait a minute, if I enter, hang on one second now. Hang on one second. Divided by 175, 223, 10. If I divide 1 by 706.4325, oh, you can't see that.
It's the same number.
It's exactly the same number. It's off by a decimal out here because our number is actually closer than theirs. They rounded. Ours is exactly correct to all those decimal places.
So that would be, so we write that as our answer right there.
You'll see on the exam, what I actually have you do is enter their number and enter your number and show that it equals the same thing out to like 5 decimals.
Okay.
That's the whole point. The point is, where did they get their magical number from? They
Yeah.
got it from our number and they converted it around.
Okay.
That's my point, Maddie.
Okay.
Yes? 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 Kurt, good. Thank you for that about the bang. I appreciate that, sir. No, I thought you were asking a different question. I thought you were saying, why do you divide it? Got it, thank you. I'm glad I had to say that. Yes? On the first page has the for example,
I'm up at about
7.5. If you take $2 away,
So why don't you just
this payout
text
is
you when I wake up on Saturday and see where you're at?
yeah, $1 million. Take $2 out of the back.
Because I think you and I can
So just go look at what I want
it's
you to
cool with us working together.
yeah, that's about right.
If we all end up with the same answers, then at least you and I can either fail and pass together. Oh, we just
Zero.
a little bit of a buffer. What's that?
No,
Sounds good.
you don't. We add up all the probabilities. Really have to add up. Yeah, over 175 million, et cetera. So, all you've got to do is figure out all of these guys. Figure out and you can figure them out, Scott. Yeah. Please, Scott, don't. And then on the are we taking out $2? Oh, no. That's part of the expectation. That's why you set this chart up right here. Is to do exactly that. Okay. Goal. Those are my questions. You got it, man. You got it. You done. Yes.
Video's gonna be up, right?
Oh yeah, I'd like to. Yeah, do it in 10 posts for sure. I have not. It's still in the file. Oh, that's still in the file. I did. I posted it online. You're good to go. Good to go, Brian. Jesse, what's up? You got your stuff? Yes, go for it.
Okay.
Yeah.
Did you turn in next week?
That is the probability of getting exactly 2 non-Powerball numbers right and the Powerball right. About 1,000. And that's the .0014. Now you see how that's the one we did. The top one is the way we did it. The bottom one is the expression of their ticket. So if you look at their ticket, I'm going to show you. If you look at their ticket, if you look at their ticket right there, they say it's 1 in 706. So I was saying, let's enter that in and let's enter ours in. They're the same number. And ours is actually better. No rounding. Make sense, Jesse? Good. Good. Put it right there. Put it right. Actually, you know what? Keep it separate.
That's what I was
Take care of that
wondering.
quickly. Take care of that quickly. Yes. Gabe, he's gonna report it like it's 1999, baby.
Did I miss something on how to actually?
Hey, you're overthinking it.
Yeah.
See, there's payouts for each of these
Yeah.
that are over here.
Yeah.
Okay. Notice how they're all $2 less than the payout.
Okay.
That's because you pay $2 to play the game.
Okay.
So basically, you have to figure these out based off of the payouts that are listed
Okay. I
over.
was just like.
Totally overthinking
I
it.
was like, how do you?
Completely
I'm
overthinking it.
like punching in numbers.
No, I mean you can, but no.
Yeah.